So I've just been watching an episode of Adrian's Digital Basement, and he'd rescued an old IBM PC, a leading edge PC, a clone, from the recycler, which is fantastic, saving old machines, definitely. And the machine worked, and he was really excited about it. It had a hard drive in it with old games and WordPerfect and all sorts of things. So I'll put a link in the description there. That was Adrian's Digital Basement. And he also did a benchmark on it of a BASIC program. And the BASIC program actually came from Noel's Retro Lab. And that's the episode there where it came from. And I'll put a link in the description. All this has got links in the description. Anyway, in Adrian's video at 42:37, he starts talking about the benchmarking. So start watching for now if you want to watch your benchmarking. But the whole video is great. And Noel's Retro Lab, he restores an old TI machine and then writes a little BASIC program for it. And then he starts running BASIC on all these other different machines as well. And he's got the results there in a Google Docs document. And this is it here. So this is Noel's results. So he's got Amstrad CPCs and Apple IIs and Atari XLs and all these beautiful old machines, Casio calculators, and so on. So you can see the different speeds for running the same BASIC program. It's only a very simple BASIC program, no graphics, nothing fancy. It's just basically printing a few dots and then a total at the end. That's basically what it's doing. So there's graphs there for all the results, and you can also see the results in seconds as well if you click onto the tab there. And so anyway, I used to love doing stuff like this when in the 80s. I had an Apple II and my brother had a Commodore 64, and we saved up all our pocket money for ages to buy them, and I worked on a farm on weekends for ages to buy it. And we used to benchmark them all the time, write different little basic programs and moving shapes around the screen and which one was faster and all that sort of stuff. And it was all good fun. And then I moved on to the PC and benchmarked that, of course. Everybody did. It was just part of the fun. And so anyway, I thought we'd take the little program, and here it is here. So it's just a little program here, just a nested for loop, printing a few dots and then printing a total. Very basic stuff. So I thought we'd run that on the Apple II and compare. And my Apple II is broken. My Apple IIC's are dead, needs repairs. Still trying to get onto that. I'm still trying to buy parts. And so what I'm running now is an AppleWin, an emulator for Windows. And so we'll get that program in there. Okay, so we just go Control C, and then go over here and go Shift Insert. And there it is. We should be able to list it and see it back again. Yep, there it all is. Okay, and we can run that now. So I'll just move that over there a bit, and I'll bring the stopwatch up, and we'll run that and see how close we get in the emulator here. And I've benchmarked the emulator, so I've done a benchmark emulator to make it the authentic speed. So we'll see how accurate the benchmark is. See whether we get. So we should be getting 36 seconds or 35 point something seconds to match Noel's real Apple II. Okay, so let's see how we go. And I might start the benchmark off and then fast forward the video so you have to wait the whole 35 seconds. But okay, so let's type run over here. Run, and I'll get ready with my enter key, and then I'll click over here real quick with the mouse. Okay, so 36 seconds, and we had 36 seconds, so we're right on the money. So the emulator is very accurate, of course, as you'd expect. Okay, so our emulated Apple II here in AppleWin, running on a Windows 10 x64 Core i7 machine, very, very closely, it perfectly matches the results of a real Apple II. And that's not surprising because the emulator authors do a lot of work to make sure the emulators are exactly accurate so that they can run games in it perfectly, okay, or as close to perfectly as possible. So so that just proves our point. Now, whoever's written any basic code before, especially for an Apple II or the old machines where the code was interpreted, not compiled. So if you write this sort of basic code on a modern machine, you wouldn't have line numbers. If you wrote it for a modern basic compiler, you wouldn't have the line numbers, and you would compile it, the code to an executable, and then you'd run the executable, and it would run lightning fast. Okay, But the old machines, especially the Apple IIs, there were basic compilers. And but if you just type this program in and ran it, it's running interpreted, okay? Not compiled, but interpreted. So what does that mean? Okay, so the Apple II starts with, if you're running on an Apple II, the Apple II starts with that first line there and converts those English commands there into something the Apple II can understand, so something that's pretty close to machine code, and runs it. Then it comes to the next line and converts that into something that resembles machine code that it can run, and runs it. It actually tokenizes it and various things, but anyway, we're not going to get too technical. And then it converts this line into something that resembles machine code and runs it, and so on. And then it runs that line, and then the next J means it jumps back up to here again and increments J, so J is now 2. Okay, so there's a loop there, and then when it gets to 1,000, it prints a dot and then goes next I. Okay, so next I is this loop. Okay, so this outer loop counts from 1 to 10, and there's an inner loop that goes 1 to 1,000. So this inner loop here is going to run 10 times, 1 to 1,000, 10 times. Okay, so interpreted BASIC is pretty slow because it's doing the interpreting as it runs it. So if it runs the same line 100 times, it interprets it. It pretends the computer has got no memory of that line of code. It converts it again into something that resembles machine code that it can run. Okay, so it's doing that over and over and over again every time it encounters a new line. So what you can do, there's a way you can optimize your BASIC programs. And so what you can do is you can make it so they, instead of taking up 8 lines of code like here, you've got a limit to line size. And I think on the Apple II it's around about 255 characters of basic statements. So 255 characters. So what you can do is you can separate lines by colons. Okay, so you can go colon S, colon 4, colon S equals S plus J, next J. Okay, so you see I'm putting all this into one line of basic code, and that's interpreted as one line of code. Okay, so it's doing all this jumping around and that inside there, and it's treating it as one line of code. So let's keep going. And again, there's some things you can't do, like if statements and that in BASIC. For the Apple II, you can't do too much. But when it's just for loops and things like that, and simple assignment statements and simple calculations, you can just keep combining them. So that was print full stop followed by a semicolon. That's to leave it on the same line, so the dots will appear next to each other. So we'll go colon, grab the next I, colon, grab the print S. Okay, so now we've got one line of code, one line of basic code. Okay, so the Apple II can now interpret that line of code and never interpret it again. It can just run all the parts of it without interpreting it again and pretending it hasn't seen it, or it's like it hasn't seen it before when it's doing it this way. Every line of code's like it's never seen it before, even if it's run it 1,000 times already. Okay, but this is just interpreting one line of code. So in theory, this should be a hell of a lot faster because there's not all those interpreting steps going on for each line of code. It just does the interpreting once. Okay, so let's now type that into our Apple II, or paste it into our Apple II. So I'll go New, and I'll go Shift Insert to paste in the code, and we'll list. Okay, so there's our program. For I equals 1 to 10, S equals 0. For J equals 1 to 1,000, S equals S plus J. Next J, print dot, followed by next I, followed by print S. That's all our code, compacted into one line. And this is an optimization trick that basic programmers back in the early 80s especially used to employ a lot, until machine code or basic compilers came out. And then you could keep your program nice and easy to understand, and that's much easier to understand than this. and then you could compile it to machine code. Then it would run lightning fast. Okay, but this is the sort of thing that basic programmers did until they could afford a basic compiler, or until the basic compilers came out in the early 80s or late 70s. Okay, so this code now should be a lot faster. We had 36 seconds for the other one. How long do you think it will take this one to run? Okay, place your bets. So I'll do a reset on the stopwatch. So the other one with the lots of interpreting. This one here took 36 seconds. and it had lots of interpreting to do because it was interpreting all these. This inner statement, for example, was interpreted 1,000 times for that loop, and then 10 times 1,000 because there was 10 loops of the outer loop. So this line of code here was interpreted 10,000 times. Now it's interpreted once, or that's the theory. Okay, so this one here should be many times faster, shouldn't it? Okay, so let's run it and we'll see what the results are. And again, if it takes more than a few seconds, I might speed up the video to save you sitting through it all. So I'll hit enter and I'll click that at the same time, and then I'll click back over here to make it so this has got the focus, this window's got the focus, so that it's got the most CPU cycles going to it. Okay, so it was 35 seconds, 35 point something seconds. The other one was about 36.5 seconds, around about there. So we're maybe about a second faster, but gee, there's not much, is it? Okay, so you've turned what was a much nicer program to understand, and you could have had rem statements in there to add comments, into something that's all on one line of code, which is much harder to understand. So there was lots of tricks to optimizing basic code, and one of the tricks was to put as much as you could that made sense. You had to pick the right lines of code, put them all onto one line of code if you could, or as few lines of code as possible that made sense. Okay, and that was one of the tricks, but there's many other tricks as well that I might do videos on those another time, but that's all I wanted to cover today. So it's confirming that the AppleWin emulator is dead accurate, and that we're getting the same results that Noel got on his real Apple II. Okay, so just a bit of fun. Anyway, hope that was fun. Thanks for watching. Have a nice day. See you next time.